Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. Tomorrow, May 15th, the TWiML online meetup is back. Our main event will be a presentation by Santosh GSK on the paper YOLO 9000, Better, Faster, Stronger, which was written by Joseph Redman and Ali Farhadi. YOLO, or You Only Look Once, is a very popular image object detection system, and we'll thoroughly review it, along with the broader object detection landscape, the current state of detection algorithms, and the various challenges ahead. If you aren't already signed up, head over to twimlai.com/meetup to register. See you there. In this episode, I'm joined by Rachel Thomas, founder and researcher at fast.ai. If you're not familiar with fast.ai, the company offers a series of courses including practical deep learning for coders, cutting-edge deep learning for coders, and Rachel's computational linear algebra course, and they're all free. The courses are designed to make deep learning more accessible to those without the extensive math backgrounds that some other courses assume. Rachel and I cover a lot of ground in this conversation, starting with the philosophy and goals behind the fast.ai courses. We also cover fast.ai's recent decision to switch their courses from Tensorflow to PITorch, the reasons for this, and the lessons they've learned in the process. We chat about the role of the fast.ai deep learning library as well, and how it was recently used to help their team achieve top results on a popular industry benchmark of training time and training cost by a factor of more than 10. I also announce on this show that I'll be working through the fast.ai Practical Deep Learning for Coders course starting in June, and I'm organizing a study and support group via the TWiML online meetup. So if you're like me and taking this course has been on your list for a while but you've put it off, let's knock it out together. You can join in by registering for the meetup at twimlai.com/meetup and letting us know that you're in on the fast.ai channel that I've created there. And now, on to the interview. All right, everyone, I am on the line with Rachel Thomas. Rachel is founder and researcher at fast.ai and an assistant professor with the Data Institute at the University of San Francisco. Rachel, welcome to This Week in Machine Learning and AI.
Oh, thank you. Thanks for having me.
Why don't we get started by having you tell us about your background and how you made your way into machine learning and AI.
Sure. Yeah, so I studied math and computer science in college, but I was really focused on kind of stuff that was as theoretical as possible. I did a PhD in math, planning to become a professor, and then kind of changing my mind towards the end. And I stumbled into working in finance as a quant, and that's where I first kind of started working with data a lot and really enjoyed it. And so I read about data science being kind of this new field in tech. And yeah, moved to San Francisco and started working for tech startups. I was an early engineer and data scientist at Uber. And then I returned to teaching because I love teaching and always, I think, come back to it in some form, and taught full stack software development to women at Hackbright. And then 2 years ago, Jeremy Howard and I started fast.ai with the goal of making deep learning more accessible and easier to use. This kind of brings together my enjoyment of machine learning as well as trying to create a more inclusive field, and really make the field more accessible. And at fast.ai, we do a mix of research and education. So our goal is we teach a course, Practical Deep Learning for Coders. It's available for free online. And we want every time we teach it to be able to teach it to an even broader audience and have even better, faster results. And so part of that is, building the libraries and tools we need to make that possible.
Okay, awesome. Well, we'll dig into all of that. Before we do, I will fess up to not having gone through the course yet. It has been on my list. And I do plan to do it. And in fact, I'll throw this out there. If anyone in the listening audience wants to do a kind of a support group or a group for going through the course, I will commit to doing it in June, so we can start in
Oh,
June
awesome.
1st. On June 1st, I should say. And we've got in our meetup, we've got a Slack channel, and I think I've already created a channel for doing the course because I'd hoped to do it sooner. But if anyone wants to join me in getting started with it in June, I think it'd be great to do it as a group.
Yeah, that's great. I was going to say we have we have forums, forums.fast.ai. So definitely check those out for asking questions and getting help. But yeah, we really encourage people to find groups to do it with, because I know a lot of people, it really helps to have that accountability and people to talk with as they're working through the course. And I know of a few different companies where groups have worked through the course together and, like have lunch once a week to discuss how they're doing.
Oh yeah, that sounds great.
Yeah. There's also this program, AI Saturdays, that we only found out about this after a while, but I think they're in like 60 countries. And it's like people get together on Saturdays and in the morning they work through the course together.
Oh, wow. Oh, very cool.
Great. Yeah. Yeah. So that's AI Saturdays.
Very cool. Well, why don't we start by having you talk a little bit about the course and go a little bit deeper into the motivation behind the course, what makes it unique relative to all of the other courses that are out there, and kind of how you see the education landscape around deep learning.
Sure. Yeah. So this is the course that I wish had existed 5 years ago when I was first getting interested in deep learning.
Mm-hmm.
And it kind of came with, I think, a lot of me and Jeremy's frustrations at the time with kind of existing materials. But a lot of resources for deep learning are they're very theoretical. And so, they're not too accessible to people that don't have a graduate math background. And even as someone that did have a graduate math background, it was not that helpful for coding. It was like, I want to build kind of like practical applications using this. And yeah, reading the theory wasn't that helpful to me. We're starting to see, I think, a lot more practical courses and tutorials out there, but many of them kind of settle for these, I don't know, they work on toy problems and have like okay results, but we really wanted something that would get you to the state of the art and that you could use in the workplace and have state of the art results, but have it be super practical. So our course is distinctive in that there are no math prerequisites. The only prerequisite is 1 year of coding experience, and it gets you to the state of the art. Something else that's pretty unusual about it is we use this top-down teaching approach. So most technical education is, we call it bottom up, but it's where you have to learn each individual like underlying component that you'll be using. And then, eventually you can put them together to do something interesting. And this is how math is taught as well. And so it's like for years, students are kind of like, what's the big picture? Why am I learning, like all these little components? And you can do really awesome stuff later, but so many people lose the motivation when they don't have that big picture. And so our goal with the course is to get you training a model right away, like in 3 lines of code. And then as time goes on, we get into these underlying details. And so this is a lot more similar to how, say, sports or music are taught, where, kids can be playing baseball, even if they don't know the formal rules. They might not have, a full team or a full 9 innings. And as they get older, they learn more rules. And so that's kind of what we're doing with deep learning, is like show you how to use it, and then we explain how it works later. And that's kind of the opposite approach for many courses.
And there are 2 courses, or at least 2 parts to the second version of the course. How are the 2 parts differentiated?
Sure. Yeah. So part 1, we call practical deep learning for coders. And that kind of goes over a lot of, I guess, like core areas of, like using convolutional neural networks for image classification. We do a little bit of language with RNNs. We also we cover how to work on tabular data, collaborative filtering. So for, making predictions of, like movie recommendations. So that's all in part 1, just kind of really to get you using the tools proficiently. And then part 2 is cutting edge deep learning. And so that's a lot more. We teach you how to start reading and implementing papers.
Oh, nice.
And it's exciting to see, because we've had a lot of students are like, oh my gosh, this is so intimidating. I did not think I would be able to like read one of these papers and implement it, but to have them doing that now.
Oh, fantastic. Well, I'll plan on hitting part 2 as well this summer.
Yeah. And releasing the updated version of that in the next month or two. So we just wrapped up the in-person version. So we kind of teach it in person and then we release it online. But that includes stuff like bounding boxes and GANs. We did some really neat stuff with language. So using transfer learning to kind of use a language model for then text classification problems, style transfer.
Oh, very cool. And the course is offered both online and in person. What's the motivation behind doing the in-person course, given that you can reach so many people doing it online?
So I think with the in-person course, one, it's really helpful to have that kind of energy and feedback. I think it's hard to record a course, just in an empty room, but to, be getting student questions. And we often really get to know a lot of the students taking the in-person course. There's been a pretty good community around it. The in-person course, I should say, it meets one evening a week in San Francisco. So most people taking the course are working full time. Most of them work in tech. As part of the in-person course, we've also had two programs. We have diversity fellows. And so this is to encourage more women, people of color, and LGBTQ people to take the course. And that's really, I think, helped us get a more diverse audience, which is great. And then we also have an international fellows program, and that's people that are remote from all over the world, but they are participating in the course in real time. And so I think that those have been really important components of the in-person course.
One of the things that I noticed not too long ago was there were some announcements about the course shifting from, actually, I forget the framework that it was using before.
So version 1, part 1 was in Keras, and then version 1, part 2 was a blend of Keras and TensorFlow. I should say, we were using Keras on top of Theano for the original version, and then we introduced some TensorFlow. But then, kind of last summer, when we started working on version 2, we switched to PITorch. And I guess actually, now that I think about it, we had used some PITorch in version 1, part 2, because we found there was some stuff that was just almost impossible for us to do in TensorFlow. And so we had started using PyTorch. This was pretty soon after it released. And it was such a fun language to use and made a lot of things feel so much more intuitive and easier. So this year, the course was entirely in PyTorch, as well as a high level API that we've written, our own library, fast.ai, that sits on top of PyTorch.
What were some of the things that were impossible to do in TensorFlow that you were able to do in PyTorch?
So I remember we were having a lot of trouble with teacher forcing. So this is in natural language processing, where for a text model where you're trying to predict, what the next word in a sentence will be. You initially, as you're training it, you want to give it the right answer initially, and then kind of with a probability, you want to be reducing the chance. So since this is an RNN, and you're predicting one word and then the next and then the next. If you always give it what the actual next word is, the network is going to be more willing to make wild predictions because it's not going to hurt it long term. But if you never give it, you can kind of get too off. And so that was something to be able to kind of have this probabilistic change happening while you're training that we found pretty difficult.
Is that something, the teacher forcing, is that an issue around initialization, or is it an issue around labels, or neither?
It's more, I would say neither. It's more an issue on kind of how you're training. Although I don't want to focus too much on that. I should say kind of high level, the big reasons we changed were, one, I think a key thing for me is PyTorch is easier to debug. And I think in any sort of coding, just being able to debug easily is really important. Mm-hmm. So with TensorFlow, and so this TensorFlow has now released a dynamic version, but for the first few years of its life, TensorFlow was just you construct what's called a static computation graph.
Right.
And so you're kind of constructing the graph, and then you execute stuff on it. And so by the time you get an error, it can feel very removed from the line of code that actually caused that error. Mm-hmm. Whereas PyTorch is a dynamic graph, and so it's when you get an error, it's right at the line of code that caused it. And so I think that feels much easier to debug. I should note that TensorFlow has released an early execution mode that is that does this and is I think more like PyTorch. This is something I think that TensorFlow is having to play catch up to PyTorch. I think they kind of saw like how successful PyTorch was with the dynamic graph, and so I think TensorFlow is still behind in this area. And it's tough because TensorFlow has such a huge code base that I think it's harder for them to be nimble when they make changes.
Right.
So that's one area. Something else that's great about PyTorch is it's just written in kind of this very standard Python object-oriented paradigm. And so I think for people that have done other Python programming or either other object-oriented programming in different languages, I think it feels a lot more natural and intuitive. Just kind of how it's structured. Whereas TensorFlow has a lot of TensorFlow specific conventions that you have to learn around sessions and scope that just kind of aren't as commonly used in other programming languages.
And so do you see PyTorch?
And I'll say one more thing about that makes PyTorch great is so TensorFlow is a much larger library, and that can be difficult because it's like, I don't know, there are like four ways to do anything you want to do, whereas PyTorch is kind of a much smaller set of features, but they were designed to be super flexible. And so it's very easy to kind of build what you want because you have these very flexible pieces that you can combine well.
Okay. And so do you think all those have made PyTorch a better choice for education, but, maybe not as strong a choice for production use cases? Or do you think it's a solid choice for production as well?
I think it's a solid choice for production as well. I think something to remember is in a lot of cases, you don't need to be training in production. And so you can train a model and then kind of have your, really you can just take your predictions and put them on like an endpoint for, if you have like a Flask app or, any other sort of app, like you don't necessarily kind of need this machine learning component in production when you're making your inferences. Like you can just kind of like have that function, attached to something else. I think that, TensorFlow, like if you need to be doing deep learning on an edge device, TensorFlow is definitely way more developed for that. And if you're doing something at Google scale where you do want to be using but which I think very few people other than Google are. So I think that PyTorch can be good for production for most people.
And to what degree has the relative lack of library community contributed components and that kind of thing, to what degree do you think that holds back PyTorch?
I think something to remember is PyTorch is just, it's crazy to think it's really, I can't remember, it was like January or February 2017 that it came out. So it's really just a little bit more than a year. And so I think that they've made great progress in that time. It is still, this kind of very young project.
And I remember when, there was this point in time, I forget how long ago it was, but I remember this point in time where, prior to, the general sense was that TensorFlow had pretty much locked things up in terms of deep learning frameworks, and all of a sudden PyTorch came out of nowhere. And then I think you all piled on soon after that.
I feel like Google has just spent so much on marketing TensorFlow that it's hard. Like, and they just have really, really marketed TensorFlow because I feel like I talked to so many people that like don't do deep learning, have never used TensorFlow, but they've heard about it and they think it's great because what they've heard sounds like mostly kind of like marketing from Google. So I think that has really impacted or kind of skewed things towards making TensorFlow seem more popular. This is also hard to remember, Keras, it's been incorporated into core TensorFlow now, but that was not originally a part of TensorFlow. And so, very first version of our course, like we were using Keras on top of Theano. Although, Theano's now been deprecated.
the space is changing so quickly.
It is, yeah.
Do you feel like it's stabilized, or do you think it
No,
could change any day now?
I think it will continue changing. Jeremy actually wrote in our blog post last year when we announced we were switching to PyTorch that basically everyone working in the field should assume we'll have to switch languages and frameworks a few more times because it's just going to keep changing possibly.
That sounds really scary for, putting on my enterprise hat, someone that wants to start, really building, real stuff and business critical functionality, the fluidity. What do you think about efforts like Onyx and some of these other things that are trying to create, either portability between frameworks or cross compilation to, different frameworks and hardware and that kind of thing?
I'm not as familiar with those, but from what I know, I think that's a great idea. Yeah, and I meant to bring up Onyx earlier as another potential solution to someone that's working in PyTorch and wants to deploy to production. Yeah, no, I think those are good efforts. And yeah, no, I mean, I said that it's changing a lot. I mean, I think that they're, if you want to be doing this stuff in production, like you absolutely can and should be right now. Like, don't feel like it's everything's going to change tomorrow. But I think there's something exciting about being in a relatively young field that is so dynamic, and where a lot of the changes we're seeing are these huge improvements.
Mm-hmm. So you mentioned that in addition to the course, there's also a fast AI library that you distribute and use in the course. And I've recently seen you publish some benchmarks that I think have something to do with that library. Can you talk about the library and its purpose,
Sure,
and then the benchmarks?
Yeah. And so the library, the goal of it, and I should also put the disclaimer, we need to release more documentation around it. And that's something that we're working on right now and will be coming out this summer. But the goal of the library was to kind of give a high level API and encode, and also to encode kind of a lot of best practices and smart defaults. Like I think something that can be overwhelming, like when you're first learning deep learning, and the kind of the impression that you get from it, some places are, there are just so many hyperparameters, and it's like, oh my gosh, I've got all these hyperparameters. What do I choose, and how do I tune those? And so we really just kind of wanted to make it easier and give you good defaults. And so if you want, you can have to really just think about like one hyperparameter, and then later on, if there's more stuff you want to change, that's easy to do as well. And to kind of have nice high-level abstractions. So that was the goal with the library. And so it's a great teaching tool, but I think it's also a good thing to use in practice. And you mentioned our benchmarks. And so this was part of Stanford, the Stanford Dawn Lab hosted a competition called Stanford Dawn Bench. And so this was for there are two categories, ImageNet and CIFAR-10, which are these classic image classification problems. However, typically, like the ImageNet competition was about being most accurate. This was about being fastest and cheapest. And, there was a baseline. You had to be at least 93% accurate. But past that point, what was fastest and cheapest?
Sounds a lot like TPC Benchmarks, if you're familiar with those.
I am not.
I think it's not TPS. That's the Office Space thing. It's Transaction Processing Council. It's like they do transaction per second benchmarks across like, big iron. And there was a point in time where commodity computers, clusters of commodity compute started to supplant the big expensive monolithic hardware boxes. And it sounds like from just kind of casually seeing some of the tweets and stuff about your benchmarks that's kind of what so what some of your results were about.
Well, so what we found, so for the CIFAR-10, which is a smaller data set, although I think it's a size that's more, I think it's like 160 megabytes, that is representative of what a lot of businesses and companies have. We won both sections, fastest and cheapest. For the ImageNet, so these are larger data set. This is like 160 gigabytes. We were the fastest on publicly available infrastructure, fastest on GPUs, fastest on a single machine, and lowest actual cost. And I should say this was Jeremy working with a group of our fast.ai students who kind of have this in-person study group that's been meeting every day. But I think it was really exciting to prove that the fast.ai library, was super helpful to this. And so, I mean, this was, it's like fast.ai library, which is built on top of PyTorch. We were using NVIDIA GPUs on AWS Spot instances. But like Google and Intel, like their general strategy in this competition was kind of just having way more hardware. And we really tried to approach it as kind of using more algorithmic creativity because kind of a core, I think, part of our mission and like the thesis we're trying to prove with fast AI is that deep learning can be accessible to people from all backgrounds and that you don't have to be able to afford like these very, very expensive clusters of machines and that you don't need to have a PhD from Stanford. And so here, this was a group of like part-time students and we're trying to do things cheaply.
Real David and Goliath story.
Yes, exactly. Yeah. We had an entry on a single machine that was faster than Intel's entry on a cluster of 128 machines.
Oh, wow.
And some of what we were doing here was just, kind of being creative with our algorithms and also using, I don't know, in the deep learning community, there's some results that have really kind of been neglected because they're not from, there's a lot of attention in the community to, like what is Stanford doing? What is OpenAI doing? And, these people that kind of have this name cachet or recognition. And so part of what we were doing was kind of implementing results from other people that are at these, less famous or less prestigious institutions.
Oh, nice.
And showing like, hey, we can use this to get fast results.
How would you attribute the benefits, the performance, the ability to run at low cost between the fast AI library and PyTorch? In other words, were you competing against other PyTorch-based entrants?
Yeah, like who gets, yeah. So I know the Google team was definitely using TensorFlow. I'm pretty sure Intel was using TensorFlow as well.
Or even what about the structure? Tell us about the structure of the task and the...
Some of the key things were, and it's interesting, the stuff we were implementing, they're actually not that complicated as ideas. So one of them is this idea of superconvergence. And this is something that Leslie Smith, who works at the Naval Research Laboratory, found. But it's the idea that you can use way higher learning rates if you lower your momentum. And momentum is kind of a factor used in optimization of, there are all these variants on stochastic gradient descent. Mm-hmm. And so momentum is kind of a commonly used part of that. And I don't know of anybody else lowering, though, the momentum part dynamically as training happens.
So backing off momentum as you're converging?
Actually, it's backing off momentum as you're increasing your learning rate to these high rates, and then you decrease your learning rate again and increase your momentum. So kind of keeping, you kind of have this triangle shape with both, and they're like inversely related.
Interesting.
So it's like, and you can check that we have a blog post where we kind of write some more details about what we were doing. But yeah, it was like learning rates increasing while momentum's decreasing, and then learning rate decreases while momentum increases. But that, allows for much faster training. And so here, this is something that, these are things that the combination of fast AI and PyTorch made very easy to implement, and having that kind of dynamic change as you're learning is something that is typically harder to do in TensorFlow. So this was, I think it's kind of hard to talk about fast AI, and it's the flexibility of PyTorch that made fast AI possible, and fast AI is fairly flexible as well since it's written on PyTorch. So that was one component. And then there was this other idea of progressive resizing, where you start out training your network on small versions of your images, which makes sense. Paul, it's kind of just trying to learn, like very, very rough, rough things. And then as training happens, you're using kind of larger and larger versions of the images. And so again, yeah, like PITorch is great to kind of have that dynamic nature.
Oh, that sounds really interesting as well.
Yeah. And this is also something I think it's exciting because it's like the ideas on their own like are not, it's not like this, I don't know, like complicated thing of math equations. It's like, hey, this makes sense, intuitively of like start training on small images and then train on larger ones. And, it's also like that way your network kind of has information about images of different sizes. And so those are, a lot of the breakthroughs, and Jeremy points this out in the blog post, a lot of these breakthroughs that have really helped us in deep learning, things like using rectified linear units for activations, and dropout, where you kind of randomly drop a lot of your weights to avoid overfitting each time, or batch normalization. They're actually fairly simple ideas, and they made things in some ways like easier to understand, while at the same time really improving the performance of neural networks. Mm-hmm. And so that we really think a lot of the breakthroughs are going to come by kind of these new insight where you can like do something differently, and not just from getting bigger and bigger clusters of computers.
Interesting. And to what extent do you think the techniques that were used in the benchmark are, practical techniques? In other words, are they kind of not gaming the benchmark with a negative connotation, but were they kind of designed to, compete well in the benchmark, but not something that you would necessarily do in practice? Or, are they all things that you would totally?
Yeah,
okay.
That there are all things you could do in practice.
Okay.
And some of them do still kind of raise issues. So one issue that we ran into, and I think is a kind of understudied issue in the field, is that how to best use multiple GPUs. I think often they kind of release with new GPUs, like how many calculations can be done on them, how quickly, but that doesn't take into account that like training your network really changes when you go from one GPU to many GPUs, and so you don't get the speed up of going from one GPU to 8 GPUs does not mean you're going to do stuff eight times faster. And so this is an area where I think that definitely needs to be more research done on kind of how do you get the most out of going from one GPU to multi GPUs.
Did you do anything with low precision in this particular benchmark?
We did, yes. And this is key to NVIDIA's new Volta architecture was key to this, because it gives you half precision floating point data. And this was something that I guess NVIDIA had provided an open source demonstration, and then we had a student that worked on this to incorporate the ideas into fast.ai, and this is Andrew Shaw. But the kind of the issue is that half precision, is kind of letting you do stuff using less space, but you do need to convert to full precision for some of the steps. So like when you multiply by your learning rate. But so that's something we've got implemented now.
Yeah, that's something that I have the sense gets glossed over a bit in NVIDIA's presentations about this. It's not like flipping a low precision switch and everything gets faster. You have to really dig into.
Yeah, because you have to think about where is it useful and not going to hurt you. Yeah, versus like where are the places where you need full precision. And I think that happens in a lot of kind of talking about hardware specs, of course, because you're just like, focused on this piece, and, deep learning is this, system that's got so many components, and thinking about how does it work as a whole.
Mm-hmm. And so where do you see the library going? Is it still evolving quickly? Is it?
Yes, it's still evolving quickly. I think we definitely still, like even coming from the competition, have a few more things we need to get incorporated. And then we really want to work on documentation and usability in terms of for new users. I think if you're working through the course, that really gives you a lot of information and context of kind of seeing how things are built. But we want to kind of make it even more user friendly beyond that. And we'll continue as we teach the course and as new papers come out, I think, and as we're doing more research, that gives us kind of more ideas of things to implement.
And do you see it primarily as an educational tool or something that
Now,
someone would use?
yes, we see it as something that would be useful in the workplace.
Okay. And to what extent, I mean, you kind of addressed this in introducing it, but, when I think of higher level abstractions, I certainly get the notion of, saving folks that are new to the field from a lot of the details, but that saving, usually comes from hiding, which can be a bit of an impediment to education and understanding. Yeah, how do you balance those two?
Yeah, that's a good question. So, I mean, some of it is this top-down teaching approach I described earlier of like initially we are hiding a lot of things, but I think having the code written in such a way that we definitely then get into the details later on, and it is written in a way that makes it easy for people to customize, and if they need to modify things on a lower level, they can do so. And so our goal with the library is to kind of be providing both of those. And this is also, I mean, I think this is something that PyTorch is good at as well. But that if you want to, add something to the library or change how it's doing something, there are places to add custom hooks and to use. I think the library is constructed to make that easy and reasonable.
And is the idea that you would, maybe use the library as a wrapper to some things that you don't want to, mess with the details about, but then, when you want to dig into those details, you would not use the library and go straight to PyTorch, or is there a...
No, I mean, I think it's, I think you would continue to use the library. It would more just be if you needed to change some, I don't know, if you're running some experiments, you're a researcher kind of doing your own thing. You can, or you're trying out a new architecture that maybe then you would need to dip into changing some of the details. But I think that our goal is to have it, and I think part of what this competition showed is that the library itself is achieving state-of-the-art results. And so it's not that it's going to hurt your performance or something to be using this high-level library.
Right. So the performance and cost objectives of this benchmark are clearly important, particularly as folks are running these types of workloads, not just on machines that are sitting on their desk, but in the cloud where they're paying for them by the minute or hour.
Right, yeah.
But another key, often maybe overlooked benchmark or metric is around productivity and the ability to iterate and innovate quickly.
Yeah.
Are there any benchmarks for that? It's harder to do.
I don't know how you would benchmark that. I mean, I would say it's almost a bit of a meme on Twitter of a lot of people saying that they use TensorFlow for their jobs, but they use PyTorch for their experimentation. And so that's what they're doing in the evenings. And I mean, there are plenty of companies using PyTorch as well, but just that I think that's part of the reason people loved PyTorch is it's so easy to iterate and kind of experiment the way you're talking about. Because I think, there are people that will say computation graphs, theoretically, that's letting the compiler optimize more. So you should get better performance with a static computation graph than with dynamic. But it's just, that's not what people have found in practice. And I think part of that is with the dynamic framework, you're able to iterate so much quicker. So you do end up kind of getting better performance. But yeah, I don't know of any benchmarks that are formally setting the distinction.
Okay. So one of the often cited barriers to folks getting into this field is the level of math that's required. And one of the things that you've done personally to try to address this is develop a class on linear algebra, computational linear algebra in particular. Can you talk a little bit about that?
Sure, yeah. So computational linear algebra. So this is a course I teach in the master's program at USF, but I've released all the videos and notebooks online. So it's the study of getting computers to do matrix calculations with acceptable speed and acceptable accuracy. And so I would say whether or not you have taken or liked kind of traditional linear algebra, this is a very different field because a traditional linear algebra course is typically, having students kind of do these matrix computations by hand, which is just a whole different set of considerations from when you're getting a computer to do them. But one of the kind of key themes of the course is the idea of decomposing matrices. And so you can think of this as kind of analogous to, like you can factor a number into primes, and that's useful, because, primes have this special property. The same idea with matrices. You can kind of factor them into component matrices that have special properties. And so the course is, it's similar teaching philosophy to the deep learning course, and that it's very code based. It's all in Jupyter notebooks, and it's all centered around applications. And so applications we look at are removing the background from a surveillance video of, identifying what's foreground and background, topic modeling for a corpus of documents, kind of digging into, Google's PageRank algorithm, because that's actually a matrix decomposition. And so kind of going singular value decomposition, which is used for compressing data. It's also used for, you can remove errors. There's a really neat example of kind of a highly corrupted data set where there's just all these errors in the picture, and you can actually remove it and kind of find what the underlying picture probably was this is of people's faces. So yeah, the course is very kind of application focused, but yeah, computational linear algebra includes a lot of things like approximate algorithms or randomized algorithms. Like often like what are the cases where you don't need to be super precise, or even, often your data only has so much precision, so it doesn't make sense to, try to get an algorithm that's going to give you something accurate to the 10th decimal place. It also looks at, issues around machine epsilon and the kind of errors that can get introduced through computer calculations.
And what's machine epsilon?
And so that's just, so the way, it's like numbers are infinite and continuous, and it's like computers are, finite and limited.
So floating point representation noise.
Floating point representation, exactly.
Okay. Well, that sounds like a really interesting class too. So this is how my classes to take lists gets really long.
Right.
And so this one isn't a structured class, but you've published all the materials online.
Yeah, all the materials online. So yeah, on GitHub are all the Jupyter notebooks, and then all the videos are on YouTube.
Oh, that sounds very cool.
I feel like I've been talking a lot about like why I like PyTorch more than TensorFlow. But I did want to bring up that I think TensorFlow has some really neat developments happening. And so I'm definitely still keeping my eye on TensorFlow. I think Chris Latner announced at the TensorFlow Dev Summit 2 months ago that they're going to be releasing it's Swift for TensorFlow. And so, Swift is the language that Chris Latner invented for iOS development. And actually, I spent several months, I guess in 2015, kind of like learning Swift and learning how to build mobile apps. And it is a really neat language that they're going to be kind of having a version of that. So it's like a whole nother language that would but it would not be just for iOS, and it's specifically for neural networks. This Swift for TensorFlow version, that's something that really interests me. And then it was kind of exciting to hear some of the new releases. Like they now have a JavaScript version of TensorFlow, which is I think really great. They have released these Google Colab notebooks where you can kind of like basically launch, these interactive examples. So I felt bad that I was perhaps criticizing TensorFlow earlier, when I do think that there are some interesting developments happening there.
Yeah, I think there's no question that Google's making some tremendous contributions with TensorFlow and that broader ecosystem.
Yeah, and right now we're using PyTorch for the course, and there are things I love about PyTorch, but I'm definitely not. In general, I'm not into saying like, hey, this is the language I'm always going to use. I hate other languages or anything. You want to recognize kind of what each language is contributing and be flexible.
So should we move on to Vim versus Emacs now?
I on Twitter recently, I just did this poll about what would you call this type of data. It got more comments and engagement than I think anything else I've ever tweeted. It was like asking programmers to name something. Yeah,
tabs and spaces. Anyone?
Yeah, generated a lot of debate.
Nice. Awesome. Is there anything else that you'd like to touch on or any final parting words for the audience?
Definitely, I just want to encourage people to check out the deep learning course. That's at course.fast.ai.
Absolutely. And if anyone who's listening wants to join me in going through the course starting the beginning of June, either hit me up on Twitter or via the TWiMLAI.com website, or just go ahead and join our meetup and you'll get an invitation to our Slack channel and just chime in there and we will get it going.
Great. No, I think it's awesome that you're doing that.
Awesome. Well, thanks so much, Rachel.
Oh, thank you, Sam.
All right, everyone, that's our show for today. For more information on Rachel or any of the topics covered in this episode, head on over to twimlai.com/talk/138. Remember, the TWiML online meetup is tomorrow, and starting in June, we'll be organizing a group to take the Fast AI Practical Deep Learning course. Don't miss either and sign up for both at twimlai.com/meetup. Okay, thanks so much for listening and catch you next time.